Okay, hi everyone. So now we are going to continue into the second masih lagi dekat first subtopic, which is extreme problem, but we are going to look at how to do this part here, optimization. So what is optimization? So optimum problem. So summary here, as you can see from the summary here, fx, y is maximum when f prime x is equals to 0 and our second derivative is less than 0. Okay, and fx is minimum when our first derivative is equals to 0 and our second derivative is greater than 0. So basically what you have already learned in an extreme problem before this by using first derivative or second derivative test, this is that we are going to apply on this optimum problem. Okay, so for optimum problem, it is very important for you to know that to know the volume and the area for these shapes here. Okay, so basically the cuboid, cylinder, sphere, cone is the basic shapes lah. Okay, so kita just go straight to the example lah. Okay, first, how to solve an optimum problem. Okay, there are 4 main steps. So the first step is basically you have to draw. Okay, obviously you have to read the question first. For this part, you have to know how to read. Okay, must know how to read. So read the question and then first draw the shape. Okay, the shape, and write the equation. Write the equation given. Okay, so the second step here is we are going to find what is maximum or minimum point. Okay, I mean, what is the maximum or minimum thing that the question asks. Okay, so let's say the question want to find the area. So your area must be in single variable. Okay, must be in single variables. Okay, mungkin macam tak faham sangat sekarang, but it's okay. So the third step here is we are going to find our f prime x and then we are going to find our second derivative. Okay, so based on these steps here, we are going to solve example 8. So let's read the question first. A rectangular plot of farmland will be bounded on one side by a river and on the other 3 sides by single strand electric fence. Okay, there you go. You have an rectangular farmland. Okay, with 800 meter of wires at your disposal, what is the largest area you can enclose and what are its dimension? Okay, here we have 800 meter of wires, something about perimeter. Okay, 800 meters of wire and we have 3 side by single strand electric fence. So first read the question and then we draw. Okay, the first step is we have to draw. You know that it is a rectangular shape. So we know that if we have a rectangular shape, here will be x, here will be x, here will be y, here will be y. That means it is the same length. Okay, so with 800 meter of wire at your disposal, so the question give us 800 meter of wire. So the question said 3 side by a single strand. Let's say we choose this side. That means this side will be 800. So the perimeter we will have 2x plus y is equals to 800. Okay, so that is your first step. Draw the shape and then write the equation. Okay, very simple. So the second step here, the question said what is the largest area you can enclose and what are its dimension. Okay, the largest area, that means the second step, the question want to have the area to be maximum. Okay, area to be maximum. Okay, so you have a rectangular. So rectangular, the formula for area is A is equals to x multiplied by y. Okay, so remember I said for second step, your y must be in single variable. Okay, for this case, that means your A must be in single variable. So we have x and y. So you have to choose. Now we have to go back to our first step. From this equation here, we are going to help this one to be single variable. Okay, so kita tak nak susahkan kerja kita, we are going to choose y as a subject. So 800 minus 2x. So now we are going to sub our y into here So that's gonna be 800 minus 2x. Okay, so now as you can see, you already have your your area in single variable. So we have 800x minus 2x squared. Okay, so that is your first step. That is your second step. Kenapa sini pun first? Second step. Okay, so make sure this is in single variable. If the question asks for volume, that means your volume must be in single variable. How to make it as a single variable? Ask help from the first step here. Okay, so now we are going to do the third step, which is the third step is we have to find the first derivative. So the first derivative, so that means dA over dx, because we want to differentiate a with respect to x. That's why we make this as a single variable. So equals to 800 minus 4x. Okay, so like usual, if you want to find the value for your x, we have to find dA over dx equals to 0. So we will have 800 minus 4x equals to 0. Therefore, you will get your x is equals to 200. Okay, so you already have the value for your x. So if you have your x, you can find your y. So let's just find our y. So y is equals to 800 minus 2 multiplied by 200. So here we are going to get 400. Okay, so the fourth step here, step 4, is we have to find second derivative. So our second derivative, d2a over dx square. Okay, so this is our first derivative. So differentiate this, we are going to get minus 4. Okay, which is minus 4 is less than 0. So ngam yang dia ialah maximum, because we want our area to be maximum. So you get your second derivative maximum. So betul lah. Okay, so now the question asks to find what is the largest area. So we want to find area maximum. Okay, so by using this equation here, you can use this equation, you can use this equation, or you can use this equation. Okay, let's say I want to use this equation sebab semua dalam x. Okay, if you want to use this equation, you can find your y lah. Okay, doesn't matter, sama je. So let's say I want to use this one here. So 800 multiplied by x, our x is 200 minus 200 square. So area maximum is 80,000. Okay, meter square. Alright, so that is how we find our maximum area. So the question doesn't end yet. Here the question asks what are its dimensions. Okay, so dimension, kalau kita tanya dimension of your room, kita akan cakap lebar ni darab panjang ni. Okay, so if the question asks for the dimension is panjang dia, which means our x 200 meter multiplied by lebar dia y, which is 400 meter. So that is gonna be your dimension. Okay, so that is how you solve our optimization problem. First step, draw and write the equation that you have from the question. Second, what is the question want? What the question wants? Okay, and then make sure it is in single variable. Third step, find your first derivative. Fourth step, find your second derivative. Okay, so now let's take a look at example 9. Okay, so now here we already have our shape here. You have been asked to design a 1 liter oil can shaped like a right circular cylinder. Okay, kalau dia tak bagi ini, kamu kena tahulah apa bentuk right circular cylinder ni. Okay, so the first step is we have to draw. Okay, so ngam lah kat sini dah draw dah. And we have to write the equation from the questions. Okay, from the question, you know that here given to us, asked to design a 1 liter oil. Okay, so this is given to us. So you have to write this one. So design a 1 liter oil, that means that is the volume. Okay, the volume of the cylinder. So volume for cylinder, balik semula kat sini, is pi r square h. So V is equals to pi r square h. So we have our volume is 1 liter all. Now we are going to use in milliliter. So 1 liter tukar kepada milliliter, we are going to have 1000 equals to pi r square h. Okay, so just leave it like that. This is what is given to us from the question. So second step is you want to find which dimension will use the least material. So when the question said about dimension, the question want about area. Okay, want something about area. So what is the area for our cylinder? Okay, untuk tahu area cylinder, ada 2 circle. We know that 2 circle is 2 pi r square plus this whole thing here is 2 pi r h. Okay, so that is the formula for your cylinder. Okay, we know that the question said the least material. Okay, least material, that means minimum. Okay, your area must be minimum lah, area minimum. So now remember, from your second step, you have to make your A into a single variable. From this formula here, we have r square, we have RH. Okay, we have R, we have H. Okay, pi is a constant, so jangan usik, biar sahaja. So we have R, we have H. We don't want to do this. We want to make it as a single variable. So ask help for first step here from the equation given here. So you want to change your R square or you want to change your H? Depends on the question. Okay, mana yang lagi senang lah. So for now, let's just make it H as a subject. So you're going to have 1000 over pi r square. Okay, so we are going to substitute H into this. So you are going to have A equals to 2 pi r square plus 2 pi r 1000 over pi r square. Okay, remember here, substitute into here. Okay, so now we are going to simplify 2 pi r square plus 2 times 1000, we will have 2000 or pi r, so 2000 over r. Okay, so that's it. Your A is in single variable. So let's move on to the third step, which is we are going to differentiate our A with respect to r. Okay, sebab r je yang tinggal dekat sini. So differentiate A with respect to r. So differentiate this will get us 4 pi r. Okay, so differentiate this will get us, dapat apa? This is 2000 r negative 1. So differentiate akan dapat minus 2000 over r squared. Okay, so next we are going to find the value of r by taking your dA over dr equals to 0. Okay, so now we will have 4 pi r minus 2000 over r square equals to 0. So kalau kita samakan denominator dekat sini, you are going to get 4 pi, ataupun kita bawa pergi sebelah pun boleh juga. So here we will have 2000 equals to 4 pi r cube. So r cube is equals to 2000 over 4 pi. Okay, and then tekan je calculator, cube root this one here, you will get 5.2. So that is going to be the value for our radius. Okay, radius for our cylinder. Okay. Okay, if you want to find the value for your H, terus pun boleh, tak ada masalah. Just substitute lah 1000 over pi 5.242 square. So here you are going to get the answer 10.83. Okay, so we have the value of R, we have the value of H. Back to the question. Question asks to find which dimension will use the least material. Okay, remember, always do your second derivative. So second derivative d2a over dr square. So this is our first derivative. Differentiate lagi sekali, kita akan dapat 4 pi plus 4000 over r cube. Okay, so to make sure that the area is minimum, we will have to substitute the value of r. So when r equals to 5.2, R is equals to 5.2. So second derivative kita akan dapat 4 pi plus 4000 over 5.42 cube. Here we'll get the answer 37.69, which is greater than 0. So this is a minimum. So ngam area kita minimum. Okay, so lastly the answer we can write as the dimension is minimum when R equals to 5.42. Okay, tulis unit dia pun boleh, tak tulis pun tak apa. And H equals to 10.83. Okay, so that is how you solve an optimization problem. Okay, so let's take a look at one more example here. Example 10. Okay, refer to the figure below. A cone has a circular base with radius r and the height of the cone is h. Given that the length of AB is 3, find the value of h if the volume of the cone is to be maximum. Hence, state the maximum volume. Okay, now we have a cone. Okay, the first step is you have to read the question and then we have to take one equation given from the question. Okay, so tak payah draw lah, kita dah ada. So from the question, as you can see, dia cuma bagi ini je. This one is given to us. Length of AB is 3 cm. Okay, so now I am going to take this part out. Okay, so kita keluarkan. This is your first step. Okay, so we are going to take this triangle out. Okay, remember from the question, macam kamu nampak kita tak ada apa-apa equation yang kita boleh keluarkan, but we know that the length of AB is 3 cm. Okay, so this is 3 cm and this is our h, our height of the cone, and this is our radius of cone. Okay, this part here. So now, bila nampak triangle, obviously you can use Pythagoras theorem. So for cone, basically the given equation is actually by using Pythagoras theorem. So we will have r square plus h square is equals to 3 square. So just leave it like that first and then just move on to the second step here. What is the question? What the question want? Find the value of h if the volume of the cone is to be maximum. Okay, so the question want volume to be maximum. Okay, volume maximum. So formula volume for the cone is equals to 1 over 3 pi r square h. Okay, remember second step, this must be in single variable. So you have r, you have h. So how can we do that? Just ask help from first step here. So you want to make your r or h as a subject, doesn't matter. Okay, tapi make sure pilih yang senang lah. Kalau kita pilih h, kamu akan dapat dalam bentuk square root. Okay, so susah. So just make our r as a subject. So 9 minus h square, and then we can just substitute into here 1 over 3 pi. This is already r square, so you don't have to squarekan lagi sekali. Okay, 9 minus h square h. Okay, so now we can simplify. We will have 1 over 3 1 over 3 pi 9h minus h cube. Okay, right, so this is our volume in single variable. Okay, so move on to the next step. We are going to differentiate our volume here. So we will get dv, differentiate volume with respect to with respect to h. Okay, so dv over dh. So the constant here is 1 over 3 pi. Differentiate 9h will get us 9. Differentiate h cube will get us minus 3h square. Okay, so now you want to find the value of your h. So just your first derivative equals to 0. So dv over dh equals to 0. So we will have 1 over 3 pi 9 minus 3h square equals to 0. Buat pergi sebelah, then we will have 3 h square equals to 9, h is equals to plus minus square root 3. Okay, so obviously we are talking about h, the height. Height tak boleh jadi negatif. So the answer here, we are going to assume h kita equals to positive square root 3. Ataupun kamu boleh buat kamu punya the fourth step, second derivative, you can substitute value of square root 3 and you can substitute the value of negative square root 3 and carilah mana satu yang maksimum. Okay, so now we are just going to focus on the positive value. Okay, so now you can already find your value for your radius. Okay, we have r square is equals to 9 minus, kita akan ambil yang positive, square root 3 square. So our r square will be equals to 6. Okay, I'm talking here about r square. Okay, so kalau r kita akan jadi positive square root 6 lah. So now the fourth step here, we are going to find our second derivative, d2v over dh square. Okay, mana first derivative kita tadi? Ini. So equals to 1 over 3 pi minus 6h. Okay, so by here we can simplify minus 2 pi h. Okay, if we substitute the value of our h, which is square root 3, when h equals to square root 3, our second derivative is equals to negative. Okay, will be negative, so that will be maximum. Okay, so betul lah dia nak volume to be maximum when h equals to square root 3. Okay, so therefore you can conclude that volume is maximum when h equals to square root 3 and r is equals to r square is equals to 6. Okay, and then the question want to find, hence state the maximum volume. Okay, so volume maximum is equals to, back to the second step, you can use this formula or you can use this formula, doesn't matter. If you want to use this formula, you have to substitute r, you have to substitute h. If you want to use this formula, just substitute your h. Okay, so I want to use this one here. So v is equals to 1 over 3 pi, r square is 6, h is square root 3. So final answer here will be 10.88 centimeter cube. Okay, so that is how we solve optimization problem.